Hello everyone. So we are solving top 50 array questions of Geek for Geeks. So today we are going to solve a very important question, and that is sort an array using Quicksort algorithm. Okay. So this is the question, and I'm going to explain you the question in a easy manner. So we will be given a array which will be unsorted, and we have to write the uh, code of a quick sort algorithm to sort the array. Okay, so here we have given the array and we have to solve it. So what is quick sort algorithm? Okay, what is the basic logic behind it? So let's discuss that. Okay, so let's say we have a array. Okay, let's say we have an array 6, 3, 9, 5, 2, and 8. Let's say this is a array which we have. Okay, and we have to apply the quicksort algorithm into this. So in quicksort, what we have to do, we have two things. Okay, we have pivot. We have to decide a pivot element, and we have to then we have to perform partition on the basis of pivot. Okay, so you can take any element as a pivot, but generally we take the highest element, the last element as pivot. Okay, so last element which is n minus one element. So here n minus one element, which the last element is 8. Okay, so we are going to take this as a pivot, and we are going to decide that how can we apply the quicksort algorithm. Okay, so we have taken 8 as our pivot. Okay, so what we are going to do, every element in the array, every element in the array which is less than 8 are going to be on the left side. Okay, and every element in the array which is higher than 8 are going to be on the right side. So we have 8. Okay, and all the elements which is less than 8 so are going to be on the left side. So it is going to be like 6 is going to be here, 9 is going to be here, 5 is going to be here, 2 is going to be here. Okay, and one element is higher than this 9, so 9 is going to be here. Okay, now we have to shift our pivot element to 2. Okay, so we have taken 2 as a pivot element now. Okay, so every element which is less than 2 are going to be on the left hand side, and every element which is right than 2 are sorry, every element which is higher than 2 are going to be on the right hand side. So we have 2, and what are the elements which are smaller than 2? We have no element which is smaller than 2. 6 is not a smaller than 2, 3 is not a smaller than 2, 5 is not a smaller than 2. Okay, so on the left hand side there is going to be none, and on the right hand side there is going to be 6, 3, and 5. Okay, now we have to shift the our pivot element again. Now we are going to make 5 as our pivot element. Okay, so now all the elements which is smaller than 5 are going to be on the left hand side, and all the elements which is higher than 5 are going to be on the right hand side. So 5 is here. Okay, and 3 is smaller than this, so 3 is here, and 6 is greater than this, so 6 is here. Okay, so we have performed the partition as according to pivot. Okay, and after that we are going from left to right. Okay, and from going to left to right, first of all we get 2. Okay, so 2, then we got 3, 3, we got 5 then. Okay, so 5, we got 6 then, right? So we wrote 6. Okay, after that what we got, we got 8. Okay, so we wrote 8 here, and after that what we got, we got 9. So we wrote 9. So in this way, you can see that we have sorted the array. This array is sorted in order. Okay. And this was the original array. Okay. And this is the sorted array. Fine. So in this is the basic logic behind the quicksort. Okay. So how can we perform the quicksort? Okay. So let's try to do that. Okay. What code we are going to write? So first, uh, let's let us do that. Which type of code we are going to write? Okay. Fine. So let's take the same array as an example. So the array was 2, 3. No, not 2, 3. Just a second. Array was 6, 6, 3, 9, 5, 2, 8. Okay. And here we will be have a low element. Okay. Low is basically the first element here. So low is going to be 0, and will we have a high. Okay. So high is going to be n minus 1, which is here n minus 1 is 5. Okay. Fine. And after that we will have a I, which is going to be initially -1. Okay. So we have low, we have high, we have I. Okay. And one thing which we will have a j. Okay. We will iterate through the array. So let's make the first of all, let's make the pivot element. So 8 is our pivot element. Okay. 8 is our pivot element. It is the last element. Okay. After that we are going to loop through the array. Okay. We are at here. Okay. We are at 6, and we are going to decide, is 6 smaller than 8 or not? So yes, it is smaller than 8. So if it is smaller than 8, so we are going to increase our I from -1 to 0. Okay. And we are at 0th index here also. So this is j. Okay. This is j, guys. Okay. This is j and this is I. So I is 0, j is 0, and what we are going to do, we are going to swap it. Okay. After that we will be in the next iteration we will be at 3. Okay. So is 3 less than our pivot? So yes, it is less than our pivot. So again, we are going to increase our I from 0 to 1. Okay. We are at 1 here as well. Okay. So I is 1, J is 1. We are going to replace it. Okay. We are going to replace ARR I with ARR I J. So basically it is going to be the same. Okay. After that, we will be at 9. Okay. This is second element. So 9 is not lower than I. So what we are going to do? We are going to do nothing. We are just going to move to the next iterator. So in the next iterator, we will be at third, third index. Okay. And is 5 less than 8? So yes, it is less than 8. So what we are going to do? We are going to increase the I again. So we are going to increase the I from 1 to 2. Now we are going to replace ARR I and ARR J. Okay. ARR J is 3. Okay. J is right now 3 and I is what? 2. We are going to replace it. So we are going to replace these. Okay. After replacing it, so it will look like something like this. So 6, 3, 5, 9, 2, 8, and 8 is going to be 8 is our pivot element. Okay. After this, we are going to move forward to our next iteration. So in the next iteration, we will be at 2, and this is the fourth index. Okay. So 2 is smaller than 8. Yes, it is. So we are going to increase our I from 2 to 3. Okay. And again, we are going to replace it. So right now, our J is 4 and our I is what? 3, and we are going to replace it. So we are going to replace these. We are going to replace this. So after performing the swap, after replacing, so it will look something like this. And here 8 is our pivot element. Okay, so now our iteration has completed, because we have to iterate through from low to high minus 1. Okay, we are going to iterate through this. Okay, so we were already at 4. Okay, so our loop is going to break from here. Okay, after breaking the loop, what we are going to do? After breaking the loop, what we are going to do? We are going to, first of all, after breaking the loop, we are going to increase our I from 1. Okay, so now I is 4. Okay, after I is 4, so what we will do, we will move our 9 to I ARR I. Okay, and we will move our 8 to its original place. Okay, we will move our 8 to its original place. So basically we are going to do this. ARR I is equal to pivot. Okay, pivot. Okay, and ARR high is equal to our whatever is in the ARR high, the original way, original thing. Okay, so I is equal to 4. Fine, I is equal to 4. This is I. Okay, so at ARR I we are going to put 8 into this. Okay, and at ARR high, which is high is what, 5. Okay, so at ARR high we are going to put 9. So after doing this, we will be left with this kind of array. Okay, this kind of array. And then what we are going to do, we are going to perform the same task again with our pivot element will be 2 from now. Okay, remember we have to uh, perform again. Okay, when I was did so, this was our pivot element. It was our pivot element. So all the smaller element from 8 are at the left hand side, and all the larger element from 8 are at right hand side. And from now what we are going to do, we are going to perform the same task for here. Okay, and after that it is going to something like this. So it will basically uh, get executed, and in the end, after all the iteration, after all the recursion, what we will have the sorted array. Okay, so this is the approach, how we are going to write the code. So let's move to the code editor and let's write the code from at there. Okay, so we are at code editor. Fine, so here we have two function. One is quicksort and one is partition. Okay, so in quicksort, what we have to do, so first of all we have to check, we have already given low and high, so we have to check that is low less than high. Okay, if it is, then we are going to make pivot index. Okay, so pivot index is going to what, pivot index is going to partition ARR low high. I know we have not to build the partition function yet, so we will do that. Okay, so please hold with me. Okay, and after that, when we have already decided our pivot index, okay, we have already partitioned according to that. So after that, what we have to do? We have to uh, perform the same thing on the left hand side and on the right hand side as well, right? So for that, we will call the quicksort function again, and at this time, this is our high is going to be pivot minus 1. Okay, and this is for the left hand side. Okay, and after that we are going to write the code for the right hand side as well. So for right hand side, it is going to be pivot index plus 1 high. This should be pivot index. Okay, so after doing this, let's write the code for the our partition. So what is going to be here? So first of all, we have a pivot. Pivot is going to be nothing but ARR high. Okay, we have I. So I is going to nothing but low minus 1. Okay, and after that we will run a loop. J is equal to low, from low to high minus 1. We are going to run this loop, and at every instance we are going to check that if ARRJ is less than our pivot. So if it is, what we are going to do? We are going to, first of all, we have to increase our I. Okay, after increasing I, we will replace it. So this is the code for replacement. Fine. So we have replaced it. Okay, after performing the loop, what we have to do after that? We will replace the we will increase the I by one more time. Okay, and after that, okay, for now we are storing the ARRI into a temp variable. Okay, and what we need to do? We need to first of all at the array of I, we need to do the pivot. Okay, and array of high, we need to do the error of I, which was already original. So we are going to do the temp. Okay, after all this, we have to do nothing but to just return the I. Okay, and yeah, so I think this code should work. So let's compile this. So yes, we our basic test cases are getting passed. So let's try to submit this. Let's see that if it is getting passed or not. As you can see, we have solved this question. Okay, so this was Quicksort algorithm by which you can sort a array. Okay, so this is the question, and next we are going to solve the next question, which is find common element in 3 sorted arrays. Until then, thank you so much.